Hey, what's going on, guys? Today, in my absence, you're gonna watch this video, solving system of equations with matrix equations. All right. Remember, a system of equations is two or more equations with the same variables. All right. Before you use methods like graphing, substitution, and elimination to solve these systems. Hopefully, you remember that from your algebra one days. A solution to a system is an order pair or triplet that satisfies all equations in the system. All right, so to solve a system of equations using matrices, you first have to set up the values in your equation into matrix form. So notice we have these two equations right here. We have x plus y equals 8, and we have 2x plus y equals 1. All right. What you want to do is you're going to write your matrix, and you're going to write this whole matrix as you're going to write the coefficients. Let's start there. All right. We write the coefficients of this matrix. So we're going to write this as 1x. Then we're going to write this as 1y equals 8. So that's why you see that there's a 1 here and a 1 here. That's 1x, that's 1y. And then we're going to write our coefficients, 2x and 1y right here in this own row. All right, now I want to point out that this matrix A is called a coefficient matrix. So first we made our coefficient matrix. And again, how we do that? We did that by writing out all the coefficients, all right, of our variables. So 1x, 1y into one row from this equation, and then 2x and 1y from this equation. All right, then we have what's called a variable matrix. All right, a variable matrix just represents your variables in the whole entire system. Okay, so we have x and y. So you make a column matrix. All right, again, this is a column matrix. All right, your variable matrix is always a column matrix. So let's say it was 2x plus 7y plus 3z. All right, 3z. Well, then you would add z to this matrix. All right, but again, you always have a column matrix for your variables. And then your answer matrix. Your answer matrix is also a column matrix. All right, so make sure you don't forget that. All right, these two are column matrices. So you have your coefficient matrix, your column variable matrix, and your column answer matrix. All right. Now, once you get that written out, make sure you know how to set this up. All right, that's part of the fight. Then to solve the matrix, all right, A times x plus b, which is just your coefficient matrix, times your variable matrix equals your answer matrix. You'll multiply both sides by the inverse, all right, because we can't divide by a matrix. Notice when we did operations last week, we did multiplication of matrices, we did addition, and we did subtraction. We never did division. Okay, you cannot divide your matrices. All right, so you got to do A inverse. So here's how it works. All right, all you need to know is once you set this up, all right, you have A inverse. Well, this is showing you the inverse on both sides. All right, what I need you to remember is what we're going to do is A inverse times B times your column matrix B equals your variables. All right, equals your variable matrix. All right. Um, And let me go ahead and show you how to do this. To solve the matrix equation, you will need to enter matrix A, matrix B into your calculator, and then calculate A inverse times B, which is what we just said right here. All right, the calculator will give you the answers as a matrix. You should then write the answer as an ordered pair. All right, so let me show you. Here is how to do it on your TI 30s. These are the written instructions. I don't have a virtual TI 30 to show you that. I can also show you that in class. I'm going to show you how to do it with Desmos matrix calculator. All right, so man, please go to Desmos with me and let me show you how to do this. We're going to do this together. All right, so before I move on, I'm just gonna write this matrix out for you, just so we can see how to do it, okay? So I want the inverse of this matrix here, um, times 1. I was about to put a division bar, and that will give me x and y, like that. All right. And so what I do is I go here, I make my matrix A first. So, oops, new matrix. And it's a 2 by 2, so I don't have to change my dimensions. So I have 1, 1, 2, 1. All right, matrix A. Then I have matrix B. All right, and I'm going to call this matrix B, my column matrix with my answers. All right, so matrix B, new matrix. And it is a 2 rows, 1 column. It's a column matrix, so it only has 1 column. All right, 8 and 1. And so remember, if you press this button, well, let's put A first. We want A, let's matrix A, but I want the inverse of that. All right, and then times B. There you go. -7, -7, 15. And that's your answers, right? Like, so remember, X was at top. X equals -7, and not B. I don't know why I put B, sorry. And Y equals 15. That will be your answers to this right here. So X and Y. And you can check it, right? If X is -7, -7 plus 15, because Y is 15, equals 8. That checks out. And 2 times -7 plus 15 should equal 1, and that checks out. That's -14 plus 15 equals 1. So that checks out. So these are our X and Y values right here. Okay. Let's set up this matrix right here, number 2. It says write a matrix equation that represents this system and then solve if possible. So we're gonna set it up first. So again, we're gonna do this. We're gonna do all the coefficients. So I want a coefficient matrix first. So I have 1x, 1y, 1z, 2x. This right here, guys. All right, please make sure you understand that is a -1 right there. All right, -1, and then 2z. And then I have -x again. I'm sorry, -1 again, sorry. -1, and then 3. And then there's a -2z, so -2. I just put the ones in red just to show that they're negative. All right, so they stand out to you. Okay, make sure you respect your operation sign. Now, look at your variables. What are our variables? And you have to, guys, we're making the matrix equation first. You have to have the ability to make a matrix equation. All right, just reiterating that. So make your equation first before you do any math in the calculator. It's easy to jump over here. Let's make our matrix first. So let's make our column matrix for our variables. All right, so we have 3 variables, x, y, and z. So we're going to put them in a column. And then we make our column matrix for our answers. All right, so our answers are 2, 1, and -2. Okay. The main thing I want to point out is, look, listen, see how 1x plus 1y plus 1z equals 2? One column. 2x minus y plus 2z equals 1 column, okay? And so on and so forth, all right? So we set it up. Now to actually solve it, we want A inverse times B equals X. All right, so in that case, when we do that, here, let me write it. I'm just gonna write it out how we're gonna put it in here. Let's use another color. Let's go blue. So we're going to say we want the inverse of A times our variable equals our column matrix, okay? And so I'm going to come back over here. I'm going to clear this out, clear all, because I want to make a new A. So new matrix. And this is a 3 by 3. So I got 1, 1, 1, 2, -1, 2. And guys, all that is a subtraction symbol. That's all that is, okay? -1, 3, and -2. All right, there's matrix A. Put that in. And then matrix B is going to be our column matrix, which is a 1 column, 3 rows this time. So 2, 1, -2. And same procedure, we want A inverse, all right, times B. And there is our column matrix right there. So you get X equals -3, Y equals 1, and Z equals 4, okay? Same procedure right here. You start your equation by making your coefficient matrix. So -2, -5, -4, -1. I almost put -x. -1, 1, 1, -3, 3, 4. Okay, and then we want our variables x, y, and z. And then we want our answer matrix, which is a column, 0, 1, and 8. Okay. And then we'll have the same exact setup. I'm gonna write it a little smaller. All right, I want the inverse of this. All right, times our answer column matrix, and that'll give us x, y, and z. All right. It's still a 3 by 3, so I'm gonna redo A. Well, I'm gonna clear all. I think it's easier just to do that. All right, A new matrix 3 by 3. So we got -2, -5, -4, -1, 1, 1, -3, 3, 4. And then we need to clear B. B new matrix, column matrix, 3 rows, So 0, 1, 8, and boom. A inverse times B was already here. So I get x equals 0, y equals -4, and z equals 5. Okay. Now I have 2 matrices right here for you that I would like you to try. On your notes, man, when I check back, look, listen, make sure you adhere to these directions. Write the matrix equation. Write the equation on your quiz and on your test. That's a question right there. All right, that's a question right there. So pause the video, you try it, and then after you try it, just come back and check your answers. I'm gonna flash the answers up here for you, okay? If you're still here, you should have paused it. Make sure you pause it. Try the problems. All right, before I put the answer up here, notice right here I put 0 in red. I did that because if you look, there's an x term, a y term, and a z term here. There's a y term and a z term in the second equation. There's no x, so the coefficient is 0, guys. All right, just so you know, 0 times x is 0. So that's why you don't have a 0 written there. It's just nothing. If there's no x variable, we don't have to, we'll just write 0 as the coefficient, okay? and then 5, 4, -2. All right, so here's your equation set up. You got your variable matrix, you got your column matrix. All right, so if you look over here, here's our coefficient matrix. Here's our B is our answer matrix, our column matrix, and then there's our variables. All right, right there. So x is -2, y equals 0, and of course z equals 1. All right. So your setup is super critical. The calculator really will do the work for you. It's just important that um, you get what you need to get done. Okay. So enter it your setup. Make sure your setup is correct. I got one more for you. Try this one. Try this one right here, number 4. I'm going to pause it again, let you set it up, let you try to solve it, and then come back to the video after you're done. All right, so hopefully you had time, you punched this in. All right, and if you're using a Desmos calculator, I want you to notice all our elements are the same, and then we got this right here. All right, we got this. You'll notice that it says singular matrices do not have an inverse. All right, what they're telling us is this: there's no solution because A doesn't have an inverse. All right, there's no solution. All right, because matrix A doesn't have an inverse. So because matrix A doesn't have an inverse, this whole thing doesn't work. We can't solve this system. All right. Now we have a couple word problems to look at. The setup is the same as long as you interpret what you're reading to the best of your ability. So I want to do this. Let's break this apart. It says 120 people attended a musical. So 120 people attended a musical. The total amount of money collected for the tickets is $1,515. Let's put that in another color. Total amount of money, $1,515. The prices were $15 for regular admission. That's still money. So I'm going to put that in green. $12 for children. That's still money. I'm going to put that in green. And $10 for citizens. The reason I put everything that talks about money in green is because that should go into its own equation. All right. Now we got twice as many children tickets as regular adult tickets were sold. So let's make a new category. All right. We got the different scenarios. We got twice as many children tickets as regular tickets were sold. All right. Um, as regular adult tickets were sold. Write a system of equations to find the number of children, adults, and senior citizens that attended the musical, then solve the system using the matrix equation. So when setting this up, guys, the first thing I want to point out is it told me 120 people attended the musical. So right now we know some combination of 120 people attended this musical. So that means some combinations of adults, some combinations of children, and some combination of senior citizens. Total to be 120 people. They attended this musical. Okay, some combination of adults, children, and senior citizens um, attended this musical. Now they told us that there was a total of $1,515 worth of tickets sold, and we know again all the prices go together. So I had $15 for regular adult admission, 15A. All right, because we don't know how many adult tickets we sold, but they know there were $15 a piece. We don't know if we sold $15 worth of adult tickets, meaning we sold one ticket. We don't know if we sold $30 of adult tickets, which means we sold 2A, or 3A. We don't know. But we do know it's $15 per adult ticket. And then we sold $12, or each child ticket is $12. All right, so we know the price of that. Sorry, I got a little tongue tie right there. So 12C. And then the senior citizen tickets, all right, are $10. All right, 10S. So some combination of these ticket prices made up $1,515. Okay. And then lastly, they told us right here in blue, it says twice as many children tickets. All right. Um, twice as many children tickets as regular adult tickets were sold. So you have off to the side here. I'm gonna set this up for you. I know that twice as many children tickets. So you have some children tickets sold. Well, that was twice as many adult tickets. All right, children tickets equal twice as many adult tickets. Twice as many children tickets as regular adult tickets were sold. Yes. All right, so C equals 2A. But in order to fit this in our matrix, we need a coefficient matrix. I need to move this C to the other side. So I'm actually going to subtract C on both sides. So you have 2A minus C equals 0. All right, so we're going to add that over here as well. 2A plus, oh, no, minus C plus 0 senior citizen tickets equals 0. 0S. So I'm going to put 0S right there. All right. And the reason it equals 0 is because C minus C is 0, guys. Okay, so there's our system of equations that we're going to now represent as a matrix. So 1A, 1C, 1S, hold on. 1A, 1C, 1S, 15A, 12C, 10S, 2A, negative 1C, 0S. And then we'll make our variable adult, children, seniors, and that equals 120, 1,515, and 0. Okay, so that's our setup right there. And then we will punch everything into our matrix and we can get our answer. All right. And again, we want the inverse, well, we want the inverse of that. Well, let me get B in first. Our column matrix for our answers. And it's just a column, so one column, 3 rows. So 120, 15, 15, 0. All right. So A inverse times B. There we go. All right. So it says the system of equations, right equation equation, number of adults. So yes. So we end up with 35 adult tickets, 70 children tickets, which makes sense. You know, you got multiple kids, you bring them to the musical with you, and 15 senior citizen tickets. Okay. All right. What am I thinking about here? We got one more word problem right here that I want to present to you. And then we will solve this one. Set it up, give it a shot, and let's see what you come up with. All right, so hopefully your setup went well. You had time to set it up. I just want to go over one caveat. It says a grocery store sells peanuts for $3.20 per pound and cashews for $8 per pound. So that's my money equation right here: $3.20 for peanuts, $8 per cashews. The one thing I want to show you that sticks out right here is it says that the grocer wants to sell 100 pounds of a mixture of peanuts and cashews that can be sold for $4.40 per pound. Well, you got to convert this. Since I'm doing 100 pounds, all right, at $4.40 per pound, I need to multiply that out. All right, so I'm going to use this same calculator real quick. 100 times 4.8. And it's simple math, guys, but 440. So this is 440 right here. Um, and this represents the amount of money per pound. So it's going to be $440 per pound because I'm trying to make total 440 to get 100 pounds of nuts. So some pounds of peanuts and some pounds of cashews equals 100 pounds. And $3.20 per pound of peanuts, $8 per pound of cashews equals $440, or $4.40 per pound. So if you did the math on that, that'll give you $440 worth of nuts. All right, or this mixture. So anyway, set your matrix up, guys, like we did. 1p, 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 1c, 3.2, 8 p and c equals 100 and equals 440. All right, that's our column right there. So when we set this up, all right, so same thing, guys. We got to make our matrix A, which is our coefficient matrix, 8. Hey, and listen, if you want to put 3.20, that's fine. It's the same thing, guys. 3.2, same thing. Well, I left it. I converted that to a whole number, so we're good. If you did not convert this, it will mess your numbers up. By the way, guys, if you don't convert this to $440, you have to convert it to the actual price of the nuts, the total. All right, matrix B, column matrix. So we got 100 and 440. All right, and now we want A inverse times B, and there you go. All right, so peanuts, and again, it says how many pounds of each type of nut should be sold. Well, we want 75 pounds of peanuts. 75 pounds of peanuts, and we want 25 pounds of cashew. All right, that's just the abbreviation for pounds. All right. Man, that's all I got for you guys. Man, rewatch it if you have any questions, and if not, man, start that practice. I'll post a key to that up online as well for you guys to check yourself. All right, use it to check yourself. Okay. And again, you got questions, just rewind it and check it out. Hopefully, I explained everything for you. I will catch you later.